Yeah, good evening, it's Charlie. Thank you very much for those who took the time to reply to the previous video looking for ideas for the next build. It was pretty clear that the consensus there is to do a single sideband rig, which I'm quite excited to do. And for those who had offered up some other ideas, I've certainly jotted those down, and the intent will be after this build's complete, I'll look to do a non-radio type build. So there were some great ideas there with things like an N-fed antenna tuner, potentially being Arduino controlled. There was QRP, SWR meters, low signal signal sources for receiver tests, frequency counters and the like. So some really good ideas there. So like I say, the intent will be after this build will be to do a non-radio build. So for this particular one, I'll just sort of go through what I'm sort of currently thinking and what I'm going to aim for, and we'll just see how things play out. So as we said, it's going to be an SSB rig. Quite keen on that. I'm either 40 or 20 meters. I'll probably settle on 40 for now, but if there's any sort of violent objection to that, please sing out, and be more than happy to change that. I'll talk a bit later on about the order in which I'm going to build it. So the frequency dependent components will be done a little bit later down track, so it's quite easy to change that to 20 meters if needed. Power wise, we'll see how things play out. I think for me, somewhere so let's say that 10 to 20 watts would be quite nice. We'll see how things play out there, and we'll talk about the power ramp in a sec. And in line with previous builds and in line with my sort of philosophy that I'm trying to do, I want to keep things simple. I don't want to get too complex with the circuit. For me, it's just about getting a nice simple radio together, and just to make it work. So that's going to be in the intent, certainly moving forward. Architecture wise, a single conversion receiver again. I'm sort of quite happy with that. It will have a 9 megahertz IF, which should be quite suitable for either 40 or 20 meters. And again, we'll look at that reason for that in a sec. So just sort of going through what I'm sort of currently thinking. This is sitting just below, with either 40 meters, it will be just below 10 megs. So I will have some, even though it's not strictly required, I will have some amplification coming off the antenna. I think in this particular build, I'm going to try and keep most of the gain, or the higher parts of the gain, after the major bandwidth determining device, which will be the filter here. So have a little bit more gain in the AF amp and the IF amp. But getting back to the start of the receiver, I am going to have a little bit of gain there. Haven't quite determined. More than likely that'll be variable gain, and probably from a simplicity point of view, that'll be just a variable resistor of some sort, just to vary the gain there. And I don't want to have too much gain down here, because I don't want to destroy the noise figure and have too much noise coming out of this radio. We'll then lead into a band pass filter, tuned for either 40 or 20 meters. So for a start off, it'll be 40 meters, and just using our standard T50 components. So we'll look at that. Into the first mixer, we mentioned on a previous video that I want to try for a start to use these ADE-1s. I got these from AliExpress. Just a word of caution, you do see a lot of these on AliExpress. They're a -1, I think, and then a -24, if I recall. And my understanding is if it's got a -24, then more than likely it's a device that's been specifically made for a specific application. In other words, it won't be per the spec sheet for an ADE-1. These ones here were sold as purely ADE-1s. They're marked as ADE-1s, so I'm sort of quietly hopeful that they'll actually work. So the intent for a start will be to mount these on a little circuit board, and we'll give that a go. So the intent, like I say, is to is to use an ADE-1 if I can make it work. I haven't used these before, and then if they turn out to be a disaster, I haven't lost very much because it didn't cost very much at all, and then I'll revert back to some SBL-1s. Again, came from AliExpress. The IF amp here, for the first IF amp, I think I'll probably stick with a, I should have said over here, more than likely it'll be just a 3904 based BJT amplifier, and I'm kind of thinking of doing the same with this amplifier here. This would be a fixed gain amp for the 9 megs, again based around probably more than likely a 3904. That leads into the filter. I am going to use this old Yaesu filter here out of an old rig, an XF92A, 2.7 kilohertz bandwidth, centered around 9 megs. So that's what it is there. I'll have to go looking for the spec sheet to find out what the expected impedance is for that. I can't remember off the top of my head. Now for the second IF amp, so again we're now past the main bandwidth determining device here. This one here I am going to try using these MC1350Ps, these little amplifiers here. They have the ability to have their gain varied. So what I'm currently thinking about is having both a manual gain control as well as an automatic gain control, an AGC. And what I'm sort of thinking about using is one of these. So this is a little MC1350P, which is a small digital to analog converter. This cost a whole New Zealand $1, so what's that, 70 odd American cents, and if I recall that was even with free delivery. It works really well. I bought this to play around with driving the x-axis on the oscilloscope to do a piece of test equipment, plotting out filters, but it's left over. I've actually gone back and ordered a whole lot more just for the sake of playing around with it. So what I was sort of thinking about doing was having some kind of sensing device down here that will sense the amplitude of the signal coming through. I would then feed that into the Arduino, and then have the Arduino drive, like I say, this digital to analog converter, and then have that varying DC varying the IF amp, as opposed to some kind of analog circuitry here that was then feeding back a varying DC. Why did I want to do this? Just because it's of interest. No particular reason. So that's what I'm sort of thinking about doing. But certainly for a start, have a manual control, which will just be a standard potentiometer, and then, like I say, I think the idea of having automatic gain control would be of use. So like I say, I'm going to try this little MCP4725. I'll just write it down there, MCP4725, and like I say, that was $1 New Zealand dollar, so not a lot at all. Now for the product detector, or the balance modulator on transmit, once again looking to use the ADE-1s, and if they fail, then reverting back to the SBL1 for that. So exactly the same as the first mixer. Now for the AF amplifier, going to have a reasonable amount of gain on this one, so I think I might just do a stock standard, and we'll do some testing with the scope and that. It'll be a combination of an NE5534P, the low noise version, as well as an LM380. So that'll be the plan there. And get a reasonable amount of gain. So hopefully between that IF amp there and a reasonably good highish gain AF amp, then we'll have a reasonably good amount of gain after that filter. Again, in terms of the whole receiver side, aiming for that sort of 90 to 100 dB gain overall. So gain, loss, loss, gain, loss, gain, gain, loss. Like I say, looking for an overall 90 to 100 dB of gain for that whole receiver. In terms of the variable frequency and the beat frequency for the mixer and the product detector, that'll come from an SI5351. This particular one here also came from AliExpress and wasn't very much at all. I bought a couple of these and they work fine, absolutely no problems at all. So that was quite good. So the plan will be to certainly use that again. I wanted, for this particular one, rather than using one of these, which is the Pro Mini, I'm going to try using, and it shouldn't be a problem, but I just haven't used one before, the Arduino Nano, a slightly different version with a few more pins, which just gives me a little bit more flexibility if I am going to look at sensing some DC voltages. It just gives me a few more analog pins to play with. So like I say, that'll be a Nano. Now for the screen itself, keeping in mind my initial plan for this is to be nice and simple, and I will say the radio will be made modular, so these will all be sort of modules, so things can be swapped in and swapped out. But for the first version, I'm just going to use a standard 16 by 2 LCD display. I particularly like the version which has this I2C backplane on it, which converts the 16 pin parallel through to, like I say, I2C. It just makes wiring it up a heck of a lot easier and nice and easy to control. So that itself there will become the oscillator, so to speak, providing both the VFO and the beat frequency oscillator. So that's what we'll do there. And like I say, being modular in nature, there's nothing stopping then down track rebuilding this portion here, and then using something like, if I was just to reach around here, something like an LCD display. Got a few of those lying around, so like I say, down track that could be an option, but for the start it'll be just a simple 16 by 2 display. So moving to the transmit side of the house, again in keeping with keeping things nice and simple, I'm going to use a little electret microphone. They're a dime a dozen, nice and easy to get hold of, so that'll be the plan for the microphone. The microphone amplifier itself, probably again just using a simple 2N3904 type amplifier, or potentially an NE5534, but probably more than likely just a nice simple BJT based common emitter amplifier, amplifying up that microphone before it gets fed into the balance modulator. Now on the transmit side, I do want to reuse this portion here. Yep, basically. So on receive, the signal will go this way, and then things will swap around and it will basically be fed into here and going back in the other direction. So looking to use probably a couple of little relays. These particular ones, funny old thing, also came from AliExpress. Funny old thing, they were also not very much at all. So I think I bought about 10 or 15 of those just to build up the junk box. So I'd probably use those to electrically switch that center portion, the IF amp at least, and the filters between transmit and receive. And when it comes to the power amplifier, still putting some thought into that one. You would have seen on the previous video there was a few comments and messages going backwards and forwards about LD MOSs. That's certainly something I haven't played around with before. I have ordered a couple of 10 watt devices, the BLF 1043. BLF 1043. It says it's a UHF LD MOS, but I see the spec sheet talks about it going from HF through to 1000 megs. So yeah, it was only $10 to get, or $10 each. I've ordered two to do a push-pull amplifier, and again, if they turn out to be a bit of a disaster, I haven't lost a huge amount of money. So that's 10 watts a pop, so between the two of them we should be able to get a 20 watt amplifier max out of that. The other option is to pull apart this. It's from an IC720 adjunct radio, so you know, there's always the option there to strip everything off, recover these two devices, and then to make up a piece of copper board that's been cut up into the circuit, similar to an amplifier that was done a couple of videos back, and then look to use some other cores that have been recently ordered, and look to do all the design work from scratch. So like I say, clear it all off and at least recover those two and go from there. So that's an option. We'll do the receiver first, and then look to build that up in due course, and then followed by a low pass filter before going through to the antenna relay that will share the antenna between transmit and receive. Now, just coming back to this RF amp here, this will be obviously the power amplifier portion. In terms of the driver, what I'm thinking, because we can reuse on transmit, if we flip this around and it sits into here, this IF amp here, I think it might be quite useful or interesting to see if we can't use that same DAC to provide automatic level control. So what I was sort of thinking there was detecting at this point here both forward and reflected power, and then if we're starting to get into an antenna mismatch situation and the reflected power was starting to climb, then we could have that DC voltage there being sensed by the Arduino, so very similar to this path here on receive, driving the DAC, and then that automatic level control, or in fact that output that was driving that that device there, the MC1350P, then effectively becomes an automatic level control. So that's what I was sort of thinking there, and so it wouldn't be that hard, I guess, at this point here to have some kind of switching arrangement that switches the input to the Arduino between the receive signal strength, and then over here would be the sensed reverse SWR. So I'll put some thought into that one, but that's what I'm sort of currently thinking. Again, so on transmit, what would have been the manual control for that one will also be in effect. So that automatic level control for the transmit power would be both manual as well as that automatic level control. Low pass filter, I think I just mentioned that before. So what else? So this, I think that's probably all that I'm currently thinking. In terms of a build sequence, I'll do what I've done in the past, and I think works quite well. Start off with the AF amp, test that, make sure that's working, and then move forward, introduce an ADE-1, and then have just a VFO coming in at the same frequency as the incoming RF, and then set it up as a direct conversion receiver for a start, which I think would be quite useful just to see if these are working for a start. That'll more than likely require at least that amplifier to be built up, just to get the signal up to enough to be able to be detected in the product detector, or the direct conversion. So that'll be the build sequence, and then start to introduce the IF amps, the mixers, so again the filter and the like, and convert it into the super het configuration after the direct conversion receiver. Right, I think I'm starting to ramble now, so I'll just check anything else I want to talk about. No, I think that pretty well covers it. There was a comment back on the previous video about cleaning up some of the Arduino code, and I totally agree with that. So I'll also take an opportunity to have a bit of a close look at that Arduino code and clean that up and make it a little bit more efficient. Interesting enough, this device here, this MC1350P, according to the spec sheet, the output DC there can go from rail to rail. So if I'm putting 5 volts VCC in, then I should be able to go from 0 up to 5 volts for interest. So we'll see how that goes. Okay, well, I'm probably going to leave that there. I think I've rambled on long enough. Any questions or comments, please sing out, but otherwise that's going to be the plan that I want to work to. So first things first, we'll start to build up this audio frequency amplifier, and we shall go from there. Anyway, like I say, 40-20 question, sing out if, which one your preferences are there. Otherwise, I'll stick with 40 meters and move forward. Okay, cheers all.